Gentlemen, ladies, none of the above, all of the above. Today we continue our foray into the big bad world of CNC machining for curious parties. We very quickly are going to run a part in here using conversational and G-code programming. This here robot speaks in ones and zeros. Unless you're counting for men speaking in pulsed grunts, we humans do not speak digital. As such, we need an intermediary language. That intermediary is G-code, geometric code. The thing is, it's not human readable. In fact, if you haven't a look at it, it's not but a bunch of gobbledygook in a textbook. No finer way than to learn something quick, fast, in a hurry than just jump right into her. So I'm going to teach you now the most important macro what I ever learned, and this is part and parcel of people being so very well versed and experienced in putting up impediments for themselves, so much so that they take it upon themselves to put up impediments for other people. I had to learn G-code, instructor at the front of the class, droning on and on. So you have to learn G-code. It's the only way. The can'ts of the world, and there are a great many can'ts in the CNC and the machining game, you can't do something. When what they really mean is that they can't do something. So I want you to write a macro right here, right now. When you hear the word can't, you think cunt. I cunt. When you say can't, you are turning yourself into a cunt. And that's the vile North American definition of the word, not the friendly Australian pass the time of day with neighbors round the way version. Before we get machining, and reiterating again, the problem with this thing is only as dumb as the operators. It will do exactly what you tell it, no more, no less. Now this thing does not know there's a workpiece in there. It doesn't even know where the workpiece is. But we do have the probe in, and it is an optical probe. There's an IR signal, infrared, just like a remote control, that sends over to a receiver and tells it when it has hit an edge. So it's essentially an electronic edge finder. But we're going to get it in close, and then we're going to use a VPS, a visual programming system, which is conversational programming, in order to tell this machine where it has to start cutting. What we're going to do is close the doors and put in the work offset into the value of G54. G54 is going to be our go-to work offset. And a work offset just means where the workpiece is positioned in the machine. So there's the G54. It was set at the last job. We go into edit, and we go into visual programming system. We go down to probing. We go down to work offsets. And then we go over to vice corner. Into the conversational now, the work offset, we're going to set it in G54. We're going to set it in 54. If we call it G54, it calls up that value. We're going to do the far left, the back left corner, which is 4x. We're going to move the probe over 1 inch to probe. We're going to move it in the Y direction 1 inch, and we're going to move it down. Well, we'll maybe make that 0.03. Enter. It's not going to probe as far down because I don't want to hit the vise, just in case. And then all we got to do is hit cycle start. There we go. It orients the spindle. It found the Z offset. Now it's looking for the X and next the Y. Now here's the thing. The probing sequence in the VPS on the Haas works. It's very robust. It works. It just works. The machining conversations, they're hit or miss. Some of them work, others don't. So if there's something that's unreliable, you can't fucking trust it. Now we know where the workpiece is, we can go ahead and machine it. No. Afraid not. We still need to tell the tool what tool and how long the tool is. Oh, what tool you want to use? I don't know either. Let's use a 3-flute end mill, rougher. That looks like pocket 15. I have no idea what tool number that is because we haven't put it into the system. That's what we're going to do now. We're going to put it into the system. So we go into manual data input. Well, first we hit reset 2 times just to make sure. Then we go into MTDI and we call up pocket P, what was that, 19? I don't recall, I got to talking. And then we hit ATC reverse and it's going to change the tool for us. That is not a 1/2-inch end mill. Once again for the second time. Close enough. Now we're using the optical tool setter, part of the WIPS, which is Workplace Information Safety something. It's supposed to be wireless intuitive probing system, but it's not particularly intuitive to me. What we're going to do here is we're going to measure the length and the girth of the tool. Again, we're going to use conversational programming to do this probing. The probing sequences, as I said, are very robust. The machining I tried them, I don't like them. So, and their proprietary blend of 11 herbs and spices is called VPS, Visual Programming System, but it's conversational. So we are going to go auto length, rotating, length and diameter. Should do it that way. And we're on tool 6. So the tool and the pocket have nothing to do with it. You don't pay attention to the pocket number once you know what tool that is. So we will put that tool number into our Fusion 360 when we do our cam scenario on the confuser. What is this? It's an end mill. It's 5.5. You got to actually physically measure that from the top of the spindle. The diameter is 1/2 inch, and the K is how much angle of the dangle it's got, how high you want it to probe it. It can't be 0, so we put 0.1 and enter. Now what it's going to do is, that's an approximate value of length. It's going to check the exact diameter and the exact length, and that will account for any run out in the spindle or the holder, and also that will give us our exact Z depth, our exact length. And it's gonna start running through, it'll bring it right over the head, start bringing it down, and just before it hits, as long as we put that length in properly, it is going to start spinning. Now we're feeding slower. It should start any time now. Now they see you coming when you want one of them little dingus, and no sense in treating her like a prom dress. She's she's pretty near a month of wages. So we go position, and we go distance to go, and back into program. Distance to go Z00. So we're on the money here. We are going to start that turning. And it's going to creep down till it touches hard. And then it's going to try it again. Touch it real gentle like. Just a kiss. Now it's checking the diameter. Same thing, comes in hard and fast. And then give her a kiss before she... Double checking. We go into the position, the offset display. And instead of work, we go to the tool. Tool 6 is in the spindle. Tells us the exact geometry. Tells us the diameter. Tells us the coolant position. That's that electronic coolant shooter. We're going to face that off. We're going to go to list program, and that's the guy we want. So we select simple milling example, NC. Now you never hit that green go button if you're not sure what's going to happen. We're not sure in this case what's going to happen. So we've gone over here to graphics. You just hit the graphics button. Now when you hit cycle start, it's going to spoof this thing into running when it's not really running. And we can see what the cutter head is going to do. We can also hit single block so that as we cycle through, each step shows us what we do. Critically important here is just having a look and making sure we don't get any errors as it comes through our program. There we go, we've wrapped it in. We have the comment out here. We commented out. We'll go over all that code. Now it's going to move in the X direction. Now it's going to move in the Y direction. Now it's going to do a linear move over. Y again, back to the start. X over, and then the other direction. Why? That's the way I programmed it, so I would have less steps. Longer run in the X. And we can see the Z is right up here, and it's never dipping down. So that's critically important to watch that Z distance. And now in the program, it also says distance to go. It's all home. Everything's home. So we're happy. Now if we take off the single block, we can run this, reset it, and run it. And you see how quickly that did the approximation. I've got the depth where it actually takes a cut commented out. So it's going to air cut a 1/4 inch above the part. We go into program, and then we go into position, and we make sure we're in distance to go. You go program, and we'll run through single blocking this whole program. I'll explain everything what's going on. I'll have the pendant on here and just hit the go button. And whatever's highlighted, when you hit the go button, it engages that command, that block. So the start of the program is the number sign. We get the green light on. This is just a comment. The program number is 0001. Here's the safety line. GOO is a rapid move. G17, I don't know what that is, I forget. There's no way to learn this other than doing dry runs. It's human unreadable. Oh, would you look at that? Somebody had the foreskin to comment out what all those mean, which never happens in the textbook for frog snacks. When you're beginning programming, you always, invariably comment what you are trying to do so that when you're trying to troubleshoot and debug the program, you know what the fuck you were thinking. Because in 2 weeks' time, in 2 hours' time, I don't know what the fuck I was thinking. So this is our safety line. It just cancels all the modal commands. The modal commands are the ones that stay on. When you call a modal command, it stays on until you turn it off. So we are turning off all of these modal commands. The G40 cancels the cutter compensation. That compensates for the diameter of the cutter. In this case, we are taking into account the diameter of the cutter in our heads when we're doing the dry run and doing the programming. G49 cancels the tool length offset. That's the previous one, in case there was another tool in there. G80 cancels any can cycles, in case there was a can cycle running, like a drilling op or something like that. G90 sets the coordinate system to absolute instead of incremental. Absolute means if I call X100, it moves to machine 1 inch from the origin, from 00 in the X plane. If I did incremental and said G91, it would move 1 inch over on the X instead of moving to the 1 inch away from the work coordinate or the machine coordinate. G98 returns to initial point after can cycle. G53. Now I was using G28, which is a move, but it moves through a point. So if there is a point there in a can cycle or something, it fucks up. So it's far safer to do G53 rather than G58. Kudos and thank you to that handsome young fella what does the Haas videos. So this brings us to machine Z-axis 0, and then it brings us to machine Y-axis 0, and then it brings us to machine X-axis 0. If you put these all on the same line, in the same block, they do them all at the same time, so it moves 3-dimensionally. Oh, it's tough to foresee a collision when you're moving in all directions all at the same time, so that's why I am doing one, then the other, then the other. And the Z always comes first because we bring it up and away. Here comes those G53 moves, the Z, then the Y. then the X. Now we're going to call tool T06 with an M06, a macro, which is tool change. Tool 6 is already in the spindle, so we don't need to worry about it. Next up is G90, the modal command for absolute positioning. Previously I was using that G28 and that needed a G91 incremental, so that is extraneous and not necessary in this case. Then we call up the offset, which we measured, G54. That's the work offset. Then from that work offset, we go to a rapid move, G00, to X minus 0.5, Y 0.5. So we're going to be positioned to the left of the workpiece by 1/2 inch and forward of the workpiece by 1/2 inch. This is what it looks like. Now we're starting to get into the scary stuff. S5000, that's the speed of the spindle, 5,000 ripms. And an MO3 is going to start the spindle clockwise. Then we are going to bring the cutter down. G43, what's a G43? G43 calls the tool offset, height of tool 06, and gives us the length, and it offsets that from the it takes into account how long the Jesus thing is. And then we're going to come off the workpiece, taking into account how long that the cutter is, we're going to come off the workpiece 1/4 inch. So we're going to be above the workpiece, and the MO8 is release the shmoo. Now I've commented that out, or it's not going to release the shmoo because I want to see what's going on during this dry run. All right, start the spindle. You can see it's getting closer and closer, and we're just correlating that Z distance to go with how it looks. Got about 1 inch, that looks pretty good. Now we stopped at 0.0, which according to the program is 1/4 inch off the workpiece. A comment didn't work. I remembered it being 2 slashes, but it's apparently just 1. So we'll go back. We'll reset the machine, rerun the program from the beginning. If at all possible, that's some advanced shit when you gotta restart a program in the middle of it. So I always hit reset and then restart the program just so there's no wonkiness there. Cycle start. We're gonna come up, we'll increase the rapids to 50. It's gonna change the tool, well, go to the home position, all that safety stuff. When you're running programs for realsies, this is a waste of time. And it's hard on the machine, all these extraneous moves. What the fuck over? Still didn't work. In any case, what every college instructor loves to hear, let her buck. Suffice it to say, we need a little more seat time on that G-code to get it right the first time around. Nothing a little edit can't fix. There's the final word on G-code. Is it useful? Yes, absolutely. Can you program with it? Yes, absolutely. It's another arrow in your quiver, another tool in your toolbox. However, you got to look at the cost of tools. And the cost of this tool, learning G-code, is a hell of a lot of seat time. You got to sit in class for a long fucking time, partner, in order to learn this shit. There is better usage you can put that time towards, such as CAD CAM, which we're going to touch on in the next video. You don't have to learn it the old school way all the time. Now, if you're taking a class and the instructor, he's got to fill that time with something. Partner, you're going to learn G-code. But if you're learning autodidactically, I ain't doing it. Fuck that. I'll learn some codes that I need to, but you cannot take advantage of all the cutter compensations and the chip thinning and all the smoothing, and the tools now are so powerful that G-code, it's to get that good at it, It's just not worth the time. Thanks for watching. Keep your dick in a vice. As the ancient Chinese philosopher Weeping Dong said, it's not whether the pussy is white or black. It's how well it skins the rat.